Hi everyone, welcome back to the DAS series. So already we have seen the various steps involved in the recursive algorithm. So 5 steps are there in the recursive algorithm. So today we have taken the example for factorial value using recursive algorithm. So this is the algorithm for factorial value. So what is the condition given here? Number 1, input. So what are all the steps involved in the recursive algorithm we need to find for factorial value. So before checking out the steps, we need to see what are all the inputs and how the output will be. For example, we shall take the value 4. So how will you calculate? Either 4 into 3 into 2 into 1 or 1 into 2 into 3 into 4. Whatever the value you are giving, either it may be 1 lakh or 100 or 1000, the initial value will be 1. And what is the final value? The given value n. So this is the initial value and final value. So definitely we need to do a basic operation of multiplication for n times. So what is the basic operation? Multiplication is the basic operation involved in the factorial value, and that should be done for n times. So 4 factorial is equal to 4 into 3 into 2 into 1. Either it can also be done this way. So in the algorithm we have followed this pattern. Why? Because we need to stop at one situation. Recursive algorithm means calling the function by itself and it will stop at one situation. So where it will stop? When the value become 1. So we shall start from 4 initial value. And when I have to stop when it reaches the base value. So what is meant by base value? Base value should be given for each and every recursive algorithm. So n is equal to 4 you consider. N is equal to 4 means 4 factorial we need to find. So when this n is equal to 0, we will stop calling the function itself. If not, f of n star, n minus 1 star n or n star f of n minus 1, both are equal. Both can be done in the same manner. N star or f of n minus 1. Both are correct. So either you can follow f of n minus 1 into n or n into f of n minus 1. So what is the value of n? 4. 4 into f of 4 minus 1, that is f of 3. So again the function call itself with a value of n is equal to 3. Why? Because 4 minus 1, 3. So 3 is the current value of n. So calling itself with the value of 3. N is equal to 3. So we need to check the base value. Base value means the function calling itself will stop when n is equal to 0. So when n is equal to 0, no, n is equal to 3 now. So again it will call the f of n minus 1 into n. So f of or else you can write it as n star f of n minus 1. Both are correct. So in the algorithm I have written f of n minus 1 into n. In the example I have written n star f of n minus 1. So 4 minus 1 it is 3. So here what we can do? So f of 3 minus 1 into n. I am following the algorithm itself. Both are correct. N star or f of n minus 1 star n, or else we will change it in any one of the situation. Algorithm we will change n star f of n minus 1. So both are correct. Both are correct. So what is the value of n now? N is 3. So f of 3 is replaced with 3 star f of n minus 1, 3 minus 1, that is 2. So what is the value of n now? 2. So n is equal to 2 no. N is equal to 0 no. N is equal to 2. So we didn't reach the base value. So again recursively it will call 2 star f of 2 minus 1, 1. So f of 1. So n is equal to now 1. What is the base value? N is equal to 0. No. Again the value will be recursively calling itself. So 1 into f of 1 minus 1, 0. So 1 into, what is the value of f of 1? 1 into f of 1 minus 1, 0. Now the n value is 0. So what will happen? N is equal, we have reached the base value. Reached the base value means a recursive algorithm is nothing but calling itself. Now the calling itself will be stopped. So stop calling the function itself. So where it called that f of 0, that will be replaced with the value 1. Why? Because we have given the value as 1, written 1. Therefore it is replaced with 1. So 1 into 1 into 2 into 3 into 4. So 1 into 1 into 2 into 3 into 4. So this is n is equal to 4 for factorial value. So that will be replaced. So we need to keep it in your mind what is meant by base value. So base value means is nothing but a function calling itself will stop at one position when it reaches the base value. So when the base value reaches when n is equal to 0, so that is the base value. So base value means what is the meaning? So when the function calling itself will be stopped. So n is equal to 0. When n is equal to 0, that is the base value, or else we can say 0 factorial is equal to 1. At that point we can say that is the recursive algorithm. So for when you are writing a recursive algorithm for any program or problem, you need to find the base value first. So what is meant by base value? A function calling itself should come to an end through the base value. So if and only if you find the base value, we will be able to write the recursive algorithm. So a base value is very essential for the recursive algorithm. So how you can frame the recursive algorithm and what is the general plan you have? The first step is input size. We need to find the input size. So n is the input size for factorial value. So what is the second one? Basic operation. So basic operation is nothing but it is a multiplication for the factorial value. So 1 is the initial value and n is the final value. So starting from 1 to n, we are doing the multiplication operation. So basic operation is equal to multiplication. What is the third step? Third step is how many times we are going to do the basic operation. Only these steps will help you to frame the recurrence relation. So you need to give more concentration on these steps. So how many times the basic operation we are doing? So when we reach the base value, we will stop calling the function itself. So until then, it will be calling the function itself. For how many times it is calling? F of n minus 1. So f of n minus 1 time again and again it is calling when n is greater than 0. When n is equal to 0, it stop calling the function. Then n is greater than 0, then what will happen? It will not return 1. It will go to the else function. That is f of n minus 1. F of n minus 1. So n star means just you are multiplying some constant value. 4, 3, 2, 1. So that constant time only. N is considered to be the constant time. But f of n minus 1 is nothing but it is calling the function itself again and again. So that you need to consider. Basic operation, how many times it is multiplying. F of n minus 1 time it is calling. So when it reach the 0, it stop calling the function itself. So that particular value 4 into 3 into, that is only one multiplication, some constant number only we are multiplying with that. So for that you can consider that as some constant time. Therefore we are writing it as plus 1. So m of n is equal to m of n minus 1 plus 1 is the recurrence relation. So what is the initial condition? That is nothing but it is a base value. When it stop calling the function itself. So when n is equal to 0, what it will do? It will return 1. That is the base. That is the initial condition. For recurrence relation, we need to frame the initial condition also. So when m of 0 is equal to 1. So when n is equal to 0, Okay, so when n is equal to 0, no multiplication operation we are performing. So n is equal to 0, no multiplication operation. So therefore we have given m of 0. No, nothing is there. So no multiplication. 0 means what is the meaning here na? Number of multiplication. So what is the recurrence relation? Again we will write clearly. M of n is equal to m of n minus 1 plus 1, and the initial condition is m of 0 is equal to 0. This is greater than 0. If it is greater than 0. Suppose n is equal to 0, then no multiplication. So now we will solve for that factorial value in two methods. The first method is the substitution method and the second method is the master theorem. So either we can solve that particular recurrence relation in any of these two methods. First we shall take the substitution method. Substitution method, either forward substitution or backward substitution method. Both can be applied to solve the last step is what? Solve the recurrence relation. We shall write the recurrence relation for factorial value. Initial condition. So this is the recurrence relation and initial condition for factorial value.